Right, so we continue to study story problems, and we will usually we get those are the kind of story problems that involve linear equations, and then we before that we already studied linear equations, right? We know how to solve linear equations. So, for solving story problems involves 3 steps. Step 1, you have to name the variable, right? Step 2, set up equation based on the given information. Step 3 is solve the linear equation. I think the most difficult part is the second part, set up equation for the variable. Usually, the variable you're going to study is the one for the unknown in the question. So, for example, let's take a look at this first example, right? I have a number such that if I multiply the number by 4 and subtract 12, I get twice as much as when I first subtract 12, then multiply by 8. So what is the sum of the digits of my number? Now, for this problem, right, you cannot name the variable for the sum of the digits. This is unknown in the question. What you have to do is name the variable for my number. Okay. Once you get a number, then you find the digits of find the sum of the digits. Okay. So this will be this will be the number, right? X. So you denote the number, my number, by X. Okay, that's the first step. Okay. Then you translate the sentence, okay, into a mathematical expression, okay, into a mathematical expression. So you know the number, I multiply the number, right? Okay, by 4. Okay, and then subtract it, 12. Okay, and this number will be compared to another one. We subtracted 12. Okay, multiply by 8. Okay, so I will get twice as much as the number on the right. The number on the left is going to be twice as much as the number on the right. Okay, so you get the equation, right? Then you know how to solve it. Okay, so it's be 4x minus 12, and this will be 16, right? Yeah, right, 16x minus 16 times 12. Now, I'm not going to multiply this out. Okay. And you will see that why, there's no need to do that. Okay, so then 12 is moved, well, you can move this term to the left, 4x to the right. It's okay. 16 times 12 minus 12 equals 16x minus 4x. All right, so you get 16 12 minus 112, so it'll be 15 12s. And then 14 minus 4 is 16 minus 4 is 12. You see? And then the answer is x is going to be 15. But that's not the answer yet. Just this is my number right here. Watch it carefully, and you just need to find the digits of the sum of those two digits. Okay, finally it's 1 plus 5 equals 6. Okay, 6 is the answer, not the 15. Right. So step 1, name the variable for the unknown in the question, but the unknown in the question is actually is a number, not the sum of the digits. Okay, so you have to do a little bit more computation after you solve for the equation. All right. The second problem. If our days are divided into 10 hours with no need for AM and PM, okay, the new hours into 50 minutes. and the new minutes into 60 seconds. What new time will be at 2 o'clock p.m.? So here we are in the two different system here, right? And the one is in the usual system, we have a PM, AM, 2 o'clock, 3 o'clock, 1 hour equals 60 minutes, 1 minute equals 60 seconds. But you can also say that 15 minutes is equal to 1 hour in another system, okay? And 6 seconds in 1 minute. So the question is, what is the corresponding notation for the same time? 10 hours. Yeah, the whole day, right? 1 day is 10 hours. Here, 12 hours. So what is the new time will be at 2 o'clock? We can say let X, okay? Denote the new time at 2, corresponding to 2 o'clock p.m. All right. So here, complete circle is 1 hour, right? 10 hours, right? 10 hours. Okay. Then X is here, right? And here we have a total is 24 hours. $24. 1 day equals 24 hours in our current system. But the same 1 day, if you divide by 10, that'll be 10 hours, okay? And so what is corresponding time at 2 o'clock p.m.? Okay, so actually it's a proportional, X over 10 should be equal to 2 o'clock p.m. 2 o'clock p.m., 2 o'clock p.m. is already, it's if in the 24-hour format, right? So it's going to be 12 plus 2 is 14. Okay, 14. So 24 hours is equal to 1 day. This cannot be changed, right? In which system. And on the right hand side, you divide the whole day into 24 hours. On the left hand side, right, you divide the whole day into 10 hours. So from the midnight to the X, right? Okay, compared to 10 hours should be equal to 14 hours over to the 24. Okay, so once you set up this equation, then you can solve it. X is going to be 14 over 24 times 10. Anybody give an answer here? It's going to be 35 over 6. Okay, from here you will get 5 over 6. Okay, at least that. Yeah, you have to change it 5 or 6 hours in the new time. All right. So at least it's 5 hours in the new time. 5 and 6, right? So we have, yeah, this is an hour, right? Now you have to convert it to the minutes and in the new time system. Okay. So 5 or 6 times 50. Right. That's going to be 41, 2 over 3. Okay. 41, 2 over 3, 41 minutes, 2 over 3. Okay, then 2 over 3 times 1 minute, 2 over 3, 1 minute, okay, is it going to be 60 seconds? No, 1 minute equals 60 seconds, and 2/3 of 1 minute is going to be 6 minutes. It's going to be 40. All right, so now you can say 5 hours, 41 minutes, 40 seconds. Okay. Yeah, this is called a proportional problem. We at the end, if we have time, we also will use a proportional method to solve the angle between hour hand and the minute hand. Maybe I shouldn't draw the circle because the circle only 12 hours, right? Complete circle. Anyway, so 10 hours equivalent to 10 hours in the new system is equivalent to 24 hours in the older system. Yeah, I wanted to take a look at the next problem, and I hope we can solve it. David and John together had $300. After giving John $20, David finds out he has $60 more than 1/3 of the amount John now has. How much does David get to John? Anyone has answers? Yeah, please don't be quiet. All right. We have an Angel. Angel, you should give me that, right? Christina, Crystal, Ethan. Jordan. Okay, can you do the problem? Jordan. Right. 7 yen. Yeah, I will give you a minute. I want to try first, okay? So you name the variable for the unknown. We want to find out how much does David now have. So you let X denote the money David now has. So 3 steps, don't skip that, okay? You have to, when you do the homework, just make sure if you want to save a little bit of time, you can say X, right? Yeah, David has X dollars now. And then you analyze the data, right? And you try to write down the equation in terms of X. Okay, anyone? Six. Story problem, right? Okay, so we denote by X amount of money David has now. Okay. Then John has $300 minus X, right? Here's David. Now, okay? Let's say now. And the John, right? If David has X money, okay, John will be 300 minus X, right? Because the total amount of money is $300. Okay. So David finds out after David gives John $20 and right. I didn't use X here. After that, now David has X dollars. So I use X still. Don't subtract 20 here because this is after he gives the money to John. Okay. So X is going to be $60 more than 1/5 of the amount of money John has. Right. So that's it. And then you solve this equation. You get 5x equals 300 plus 300 minus x, and x is going to be 10. No. Okay. And the x is the 6x. Let me finish it. 600. Okay. Then x is going to be 100. So yeah, it's $100. Okay. $100. Michael got 116. So you see, this is a pretty tricky problem, right? $20 after giving John $20. But if this is 20 is not used in the computation, it's kind of misleading, right? Because we did not buy X, the amount of money David has now. Okay. Right. So I didn't use 20 in the equation. Where is 20? That's a good question. Where is 20? Well, 20 is already given to John. All right. If you can, if you really want to include in 20, then you cannot let X to be the amount of money David have. You can say before that, right? Before giving $20, right? To John, right? And I can assume David has. I'm going to use a different variable, and John has 300 minus y, right? Then after give, then y minus 20, right? And then John gained $20, so 320 minus y, right? And then you have the equation y minus 20 equals 60 plus 1/5, 320 minus y. But when you get the y, okay, and that is the amount of money David had before he gave the money to John, right? So actually it's going to be 120, okay, honestly. Then you subtract 20, you still get $100, okay? Because we're asking how much does David now have after he gave $20 to John, okay? Yeah, just be careful, yeah. So then y minus 20 is going to be 100. That is what money David has now. Okay. So X is not used. The $20 don't need it to be used. Okay. All right. So now go back to the solution problem. Right. A solution contains 3 ounces of active ingredient and 9 ounces of water. Okay. Please work on this. So how many ounces of water should evaporate so that the ratio of the active ingredients to the solution is 3 to 7. Right. how many ounces of water should evaporate. Okay, so we let X denote denote the amount of water needed to be evaporated. To be evaporated. Okay, so then you try to write down the equation. Okay, then you try to write down the equation. What do we want to do? We want to, solution contains 3 ounces of active ingredients, 9 ounces of water. So we already know, okay, okay, this is a 3 ounces, okay, active ingredients. The ingredient, this is water. Okay, water is 9 ounces, right? Okay. So total solution, right, is going to be 12 because 3 plus 9 plus 5 plus 9, yeah, is 12, right? Total. So read the question carefully, okay? So now we want to evaporate the water. So this active ingredient is still 3 ounces. 9 minus X, okay? Because this is a portion, portion of water. Yeah. Are gone, right? And the solution will be also decreased by X ounces because it's some water evaporate. Now what we want to use this is a solution. Okay, why? Because in the question, okay, so the ratio of active ingredient to the solution, not to the water. Okay, so be careful. Solution is 3 to 5. So that's why 3 over 12 minus X is going to be 3 over 7. Okay. All right, so now once you set up the equation, you can solve it. Okay, you can solve it. The 3 is gone. It's a 3 equal 12 minus X. X is going to be 12 minus 7. And that is going to be 5. And you got 5. Okay. Right? Andrew, did you get the same equation?
Yeah.
Yeah, it's important to write down the equation, okay, to solve story problem. You cannot just work on scratch paper, right, and come up with a number, okay? You have to write down clearly so other people can understand it, your teacher can understand so that he can grade it. Otherwise, just look at the answer is wrong, then you get 0, right? Points, 0 credits. But if you're in college, you really want to get partial credits, okay? You want to get partial credits for some complicated problem. If you don't know how to express it clearly, you're not able to get partial credits because your answer is wrong. Okay. All right. The next problem, I want you to figure it out by yourself. Okay. You have to name the variable. Okay. A runner starts at the beginning of a runner's path. Yeah, draw the picture. Okay, draw the picture, and runs at a constant speed, 6 miles per hour. 66 miles per hour. And 20 minutes later, the second runner. So 20 minutes later, the first one is already here. The second one is here. Right? You're running at a faster speed. The fastest speed, 85 miles per hour. So you believe, 20 minutes later, right? But if the second one runs fast, so therefore, eventually the second one can catch the first one. That's common sense, right? Now, how to set an equation for this problem. We can do some computation. 66. Yeah, what is the question? Right? Question is how long take the second run to reach the first one? Then we can say t hours. Okay. So we're curious, 20 minutes later, what is distance, right? This is the keep the distance here. Okay, so it could be 60.6 times 20 over 60. Okay. So that is going to be I think it's 22. All right, so then we click the clock, right? Then the first one is already here. We're going. Imagine the second is faster, right? Somewhere when they catch, they have the same travel the same distance. Okay, so in 2 minutes, the second runner. Okay, this is the second one. It's the first one. Okay, the second runner travels 8.5 times t. Yeah, runs 8.5 times t, right? The first runner, how far away from the starting point? It is going to be 2.2 plus 60.6 times t. And then if the second one will catch the first one, then these two should be same. So they're equal. So this is the equation we get. So now let's simplify. So you will get 1.9, 22.2 equals 1.9 t. So t is going to be 2.2, 1.9. And after simplifying, it's 1.16 hours. I don't know if you get this answer. Yeah, you have to draw the picture and imagine when the second runner starts to run, right? Boom, right? Then run pretty fast. Okay, so 2 minutes later, where he is, right? He's here. The total distance he travels is going to be, 8.5 t. Right? So you have to calculate the distance the first runner travels. Right, then you add it together, right? 22 miles plus its speed. Then that should be equal when you solve the equation. All right, so that's the second. All right, now this is also a typical problem going that direction, the water, right? A boy can row a boat at constant rate in still water if there's no flow, water flow, 6 miles per hour. And then he upstream 40 minutes. He rows upstream for 40 minutes and rows downstream, returning to his starting point for 20 minutes. So going that way, it takes him 40 minutes, and make a U-turn takes him 30 minutes. Okay. So 20 minutes here. All right. We want to find the rate of the current. Okay, how do you get the equation? So the rate of the current will be x mile per hour, okay? How do you set the equation? Okay, so how do we solve this problem? We have to, we have to check the combiner speed, right? And against the stream, upstream, right? So the speed is slow because the speed is going to be 8 minus x, okay? And this is a mile per hour. And here will be 8 plus x mile per hour. Right? So return to the same point means what? They travel the same distance, okay? 8 minus x times 40 minutes, so 40 divided by 60 should be equal to 8 plus and 20 over 60. Yeah, because it's 20 minutes have been converted to an hour, so 20 over 60. But in this equation, 60, 60 can be canceled out. So that's it, you simplify a little bit. And this is 8 minus x, this actually is 2 over 3. And 8 plus x is going to be 1 over 3. Right, and actually even cancel 3 on both sides. So I get 2 times 8, 16, minus 2x equals 8 plus x. So x is going to be 8 over 3. Wait a minute. Yeah, 8 over 3. Right, this is a mile per hour. So someone says 4 miles per hour. Aha! We draw the picture to set the equation for the distance. That's a key point. Because when we don't know the distance actually exactly, right? But we know the combined rate. When is the x minus x, other one is 8 plus x, depends on against the current or with the current. Then you compute the distance because they travel the same distance, forward and backward. Then you get the equation. Okay. If you couldn't solve this problem, and try the next one. This is also a very typical problem. Okay, draw the picture. Okay, a water tank can be emptied by using my pump A and pump for 8 hours, and the water tank can be emptied by for 5 hours by using pump A and pump B together. So how long will it take to empty the tank if only pump B is used? All right, so what you could do, you name the variable. This is called x. Okay, x hours. Okay, take x hours to from pump B to empty the tank. I wanted to try. And Crystal. Oh, Crystal, good job. Right? Any questions you can get? Okay, so we don't know how big of the tank, right? And I want to know the rate. So we assume that there was a V gallons of water, for example, right? Okay, so the pump A, the rate is going to be V over 8, right? Now, I don't know the rate of pump A, and the sum of the rate of the sum of those two rates, okay, is going to be also can be calculated as V over 5, because it takes both of them to empty the tank within 5 hours. Okay. Now we want to empty the tank by pump B only. Okay. How many hours, right? So it's just the rate V is going to be V over X, right? Right? Right. So what do we get? We will get V over 5 equals V over X, V over 8. Okay, that's it. And there's additional V there, but this can be removed. All right, then from here, you know how to solve it for X, right? X is going to be 1 over X is going to be 1 over 5 minus 1 over 8. So X should be equal to 40 over 3. So this is the answer, right? Great. Yeah, you can estimate, it's about 13.3 hours. So you have to be briefly introduce some variables. Those variables, some will be used, some will be canceled out. Okay, if you're not given the volume of volume of the tank, then you can assume that it's just V, or assume it to be 1. All right, so try next one. It's about swimming pool, okay? It's different probably. So now, if with the water from one hose, swimming pool can be filled in 4 hours. If the second hose is added, and it can fill the pool in 1.5 hours. All right, so let's try to solve this problem, right? So we still don't know the volume, so we can say V, right? right? V, okay? And there will be larger one and short one, up, and the larger holes and the smaller holes. So it says, so the rate for the larger one is going to be V over 4, right? And the rate for the small one is V over X. So the combined rate, right? The combined rate. The combined rate is when the second one is added. Okay. So combined rate, so it fills a pool in 1.5 hours. So it's V over 1.5. Then I think it's easy to find X. Okay, you put everything there. So V over 4 plus V over X equals V over 1.5, and VV canceled out. Okay. So X is going to be, and that is 2 over 3. All right, so now you can, let's see. Yeah, then you can solve for X, right? So let me rotate. Let me, yes. So let me redo it. Okay, you get this equation and the V canceled out. 1 over X equals 1.5 minus 4. Right, then you simplify, right? So 1.5 is, you can use a notation, it's going to be 2 over 3 minus a quarter. Right, 2 over 3. Yeah, so then they have a 12. 8 minus 3 is a 5 over 12. Okay. Then X is going to be 12 over 5 again. Great, Michael, good job. Right, so this is it's about, yeah, it's not, it's exactly 2.4 hours. So this is the equation using the rates, okay, then you solve the problem. Right, so this is the equation, those are this. And put that, then you get the equation X. All right, our next problem is about the time. We have to, we have to draw the picture here to see order to solve the problem. Okay, at 5:15 p.m., what is the angle between the minute hand and the hour hand? So we have to draw the picture here. Okay, this is a minute hand. Okay, and this is hour hand. Okay, it's about 5:15 here, right? Here. Right, we want to find the angle between them. Okay, how do you find this angle? Okay, think about that. This is a picture. This is our hand, right? This is a picture only for the minute hand. And this is a 5 o'clock, this is 6 o'clock, right? So this angle, when you rotate the minute hand to complete one circle, the hour hand only rotated for how many degrees? How many degrees? Right? 60 degrees, right? Or 30 degrees. the picture is not precise. Let me draw the hour hand here. Okay. This is 3. Here's a 4. Here's a 5. Okay, this should be the picture here. So when the minute hand rotate 360 degrees, okay, the hour hand to rotate from here to here 30 degrees, right? 30 degree, the hour hand, right? And the equivalent to the completed circle, right? Completed circle 66 minutes. So it's really the minute hand completed 360 degrees, right? Right. So that's the relationship, correspondence. That's okay. So if this is angle theta, tiny bit, right? Then this angle will be, this angle, this angle, let's call the x, okay, degree. What's the relationship between these two? Well, theta over 30 degree, okay? This should be equal to x degree over 60 degree, right? Or 360. Okay, got it? Yeah, this is correspond because when x increased from 0 to 360, theta increased from 0 to 30 degrees. Okay, so now we know that at 2 hours 15 minutes, right? This is the x is going to be, right? It's going to be 90 degrees, right? Right. So then you have theta 30 equals 90 degrees over 360 degrees. So after you simplify, and that is going to be 7.5 degrees. Okay, 7.5 degrees. So now the angle between the minute hand and hour hand, this is a minute hand, right? So you have the total, you have 60 degrees plus 7.5 degrees. So the angle between them. And that is going to be 60 degrees plus 7.5 degrees. Okay. Okay, so you thought it was our hand at 5 and then our hand at, no, I'm talking about the minute hand and our hand, okay, the angle. The angle changes. It's pretty complicated, right? The angle changes. Okay, maybe you can find a formula for that. Okay, can you find a general formula? Okay, do not mention the specific angle, right? Find the general formula. Okay, find the relationship, right? What is the angle between, right? So in general, right? In general, theta degree equals 30 degrees over 360 degrees and x, right? And that is going to be divided by 12. Okay. So, so that's the relationship between those two angles. Okay, let me repeat again. yeah, that's the relationship between our hand and this. Okay. So yeah, so let's see. Okay. This is a minute hand. I can draw slightly different. This is a minute hand, and here's X degree, and you can assume it's a 5 o'clock. No, that's better notation. Okay. Okay, this is the angle here, theta. Okay, so then you will see, yeah, you see the relationship, right? Now again, when if it's complete circle, right? Okay, then theta is going to be 360 degrees divided by 12, and that will be right. That'll be 30 degrees. Okay, that means when the minute hand complete the whole circle, then the hour hand change, the angle changes 30 degrees, okay, from here to here. So the angle between them is going to be what is the angle between them? Angle between them a little bit difficult. You have to say from here to here, right? So this is what is 5 o'clock, right? It's going to be 90 degrees plus 100 degrees minus 30 degrees, so 150 degrees, right? Okay. So you can get a slightly more general formula, okay? So the angle between the hour hand and the minute hand is going to be, it could be which, I don't care which one is first, just difference of those two angles. The difference between these two angles, so one is the X degree, right? Okay, that is the X degree, minus 150 degree plus theta degree. Do you agree? Yeah, that is A, right? Because yeah, 150. That's a 5 o'clock I'm talking about. This 5 is not changing, okay? Right. So 180 minus 150 is 150. Yeah, 180 minus 30 is 150. And the angle from North Pole, you have to have a references, right? Point. So the angle from here to here is a 150 degree plus theta degree. So I can replace, that's two variables here, but that is the relationship here we already find out. You can assume, doesn't matter which one you want to choose, right? You can say theta X is going to be 12 theta, right? So I can put 12 theta here. Okay, but this is less useful than the, that's 11 theta minus 150, okay? But it's, I think it is more difficult to use because you have to figure out theta, right? Given at what time, theta. So I think X is easy to see, Yeah, change it to X, then this is going to be X naught minus 150 degree plus, okay. So you will get 12, I think it's 11 over 12. Okay, so that is the formula. Right, and you can choose another time, right? So this is angle at 5 point, I should say some minutes, but we don't know what is that, right? So, but the corresponding angle is going to be, yeah, sum of, I'm going to put y here, some here, okay? Okay. So at 5 part y p.m. And then you know that, right? Y equals 15 means y equals 15 corresponding 90 degree, right? Y equals 30, and this angle will be, 180 degree. Okay, so you can easily calculate this. You can get a general formula. You can easily calculate as an angle if you're able to derive the formula. All right, it's yeah, I'm going to ask you to do the next problem. Find the angle, okay, between the hour hand and the minute hand. Okay, at let me say at 2 o'clock at 2 o'clock 45 a.m. for example. Okay, can you do this problem? Okay, so first of all, you draw the picture, right? And 2 o'clock, and this is a 3. Here's a 1, here's 2. So somewhere here, the hour hand, right? The minute hand is going to become here. So you're looking for the angle. I don't know which angle. The angle could be like this, could be that. Doesn't matter. It's a difference, right? So usually we were talking about this angle smaller than 180 degrees. So this is the angle you're looking for. Okay. To determine that angle, all you needed to do is to draw the line. That's my hint. Determine that angle, this tiny bit angle, right? Yeah, because here's a 90 degree already. This is a 60 degree, right? So you just need to find that tiny bit angle. Right, anyone has answer? Okay. So how can I get theta, right? Theta compared to so this is 30 degrees. Sorry, yeah, 30 degrees. Theta compared to 30 degrees, okay, is going to be the 360 degree, and this is 270 degree, right? Right? Yeah, because the complete is a minute hand rotated from here to here is 270 degree. Okay, so the hour hand rotated theta, right? So then from here, theta equals, so you can simplify it. Okay, once you simplify, then you, yeah, then let's calculate, okay? So 30 times 270 divided by 360, so it's 210.5 degrees, right? So that is theta. Once you get theta, then you can find length. So the angle between them is going to be 90 degree plus 30 degree plus theta. Okay, 120 plus 22.5 degree is a 140. I think it's 142.5 degree. Yeah, that's my computation. I'm not sure it's yours. Let's double check the work. Okay, 30 times 270 divided by 360. I think it's 2.20. Yeah. Okay. What is 120, right? 120, see, this is, I'm talking about this angle, okay? Now, you can also, yeah, the other angle is, there's two angles here. We take the smaller one, right? We take the smaller one. Yeah, 120, this is a 120, right? Add them together. Okay. All you have to do is just find the theta and use a proportion, right? Theta compared to 30 is going to be 270 compared to 360. That's it. Then you get the angle, right? Yeah. So a little bit challenging. Yeah, this is called proportional problems. Okay. Yeah, you draw the picture and imagine, this when our hand increase, minute hand increase, right? From North Pole rotated counterclockwise, if it's complete the whole circle, then theta increase from 0 to 30 degrees. Okay. So theta over 30 should be equal to the angle over 360 degrees, that angle right now, 45. Yeah. Okay, that's 270 degrees. All right, let's stop here. I'm going to give you the homework assignment.